Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 14.2, Problem 12. This is Section 14.2, Problem number 12. It says, what is the minimum amount of material required to construct a cylinder with a capacity of 16,000 cubic centimeters? So that's approximately 4 gallons, just to give you an idea. So this is more of a pail than a can. So if you have a cylinder, again, you can think of it as a can. So like I say, for 4 gallons, this is more of a pail, but it would have this sort of a shape. And you want how much material? So the material required to construct a cylinder is basically a rectangle with a circle above and below it. Like if you squash this flat, that's what the material would look like that makes up the cylinder. The top and bottom circles are the top and bottom of the cylinder, and the rectangle you get is the wall of the cylinder if you flatten it out. So to make that cylinder, you want to make it with a minimum amount of volume. So if you're a business, you don't want to, with the minimum amount of material, I say, for a fixed volume, you don't want to use up more material than you need to. Waste a lot of money. If you have to make one of these pails, then that's fine, you just make it. But if you have to make thousands of them, you certainly want to make it as cheap as you can. So the total amount of material, let's call it S for surface, equals, so each circle, the area of a circle is pi r squared. But now you have 2 of them. There's one from the top and one for the bottom. So there's 2 pi r squared plus the rectangle. So for the radius of a circle to be r, the base of the rectangle is basically the circumference of the circle, which is pi times d for diameter. So the diameter is 2 of the radius. So it's 2 pi r, not squared, just 2 pi r. That's the circumference. So it's going to be 2 pi r, that's the base of the rectangle, times the height of the rectangle, which will be the height of the cylinder. So 2 pi r times h. So here's my function of surface. I have 2 variables. That's the problem. Again, it looks like 3, but pi is not a variable. It's just 3.14. R is a variable, h is a variable. I have to have only 1 variable. Once I get it to 1 variable, again, I'll take the derivative, set it equal to 0, solve for my 1 variable. Now, to get it to 1 variable, the key to this is to remember that it said you have to have a volume of 16,000 cubic centimeters. So the volume of a cylinder is the area of the circle that it covers times the height. So 16,000 must equal the area of the circle, which is pi r squared, that's the area of the circle based on its radius, times the height of the cylinder. That's the volume, and it has to come out to 16,000 because that's what the question says. Now I can solve that for either r or h and then take the answer I get and plug it in here. It's going to be easier for me to solve for h for a couple of reasons. H is only to the first power as opposed to the r to the second, and the h only shows up in one spot in the function that I have for surface. So let me divide both sides by the stuff that's being multiplied times the h. So the right side of my equation divided by pi r squared, and the left side of the equation divided by pi r squared. So I get 16,000 over pi r squared is equal to h. So now that I know what h is in terms of r, I can plug it into my function. So now S, the total surface of my cylinder, is equal to 2 pi r squared plus 2 pi r times h becomes times that value, 16,000 over pi r squared. So now I've got it with just 1 variable. So I'm going to go S prime, set it equal to 0, solve for r. Now before I do S prime, I can clean this up pretty well. So let me do S equals 2 pi r squared plus, well, this 2 I can't cancel with anything in the bottom, but pi in the top, pi in the bottom, I can cancel those. R squared in the bottom, r in the top, I can reduce the r in the bottom to an r to the first power, cancel the one in the top. So I have 2 times 16,000, that's going to be 2 times 16,000 is 32,000. And that r in the denominator, let me write that in the numerator as an r to the negative 1 power. So now I have a function for surface area in terms of only one variable r. It's been simplified to the point where I can just do s prime without any derivative rules like quotient rules or product rules. I can just do the derivative. So the derivative is s prime equals the 2 pi r squared is going to give me a derivative of 4 pi r to the first. So again, the exponent of 2 came down times the number in front, which is 2 pi. So 2 times 2 pi, that's my 4 pi. R to the 1 less power, that second power drops down to a first power. And the next piece, 32,000 r to the minus 1, the derivative of that is negative 32,000 r to the, careful with the exponent, negative 2. Right? So that derivative came from the exponent of minus 1 coming down times the number in front of 32,000. Negative 1 times 32,000 is negative 32,000. R to the 1 less power, that minus 1 power drops to a minus 2 power. So there's s prime. The next step is set s prime equal to 0. So I'm going to go 4 pi r minus 32,000 r to the negative 2, which I'll actually write as 32,000 over r to the positive 2, because it's the same. It's going to be a little easier to deal with like that. And it's going to be equal to 0. So solve for r. So I have a negative 32,000 over r squared on the left side of the equation. I'll bring it to the right side. It'll become positive 32,000 over r squared. So on the left, I still have 4 pi r is equal to now 32,000 over r squared. So to solve this for r, what makes it problematic is I have the variable in the denominator. Easy enough to solve. So whatever the denominator is, I can make it go away. Multiply both sides of the equation by the value I want to cancel out of the denominator. So the left side of my equation times, in this case, r squared, is equal to the right side of my equation times the same value, times r squared. So on the left side, r squared times 4 pi r will become 4 pi r to the third, right? That r squared times r to the first is my r to the third. And on the right side, 32,000 over r squared times r squared, r squared, r squared, they cancel. 32,000. So now the equation I have to solve is 4 pi r cubed equals 32,000. Well, let me reduce by 4 right off the bat. Divide the left by 4, divide the right by 4. I have pi r cubed equals 32,000 divided by 4 is 8,000. And I really could have gotten rid of the pi at the same step. So let's divide out the pi. So I have r cubed equals 8,000 over pi. That's r cubed, though. I want r. So I have to undo the cube. So again, because it's an equation, the rule is I can do anything I want as long as I do the same thing on both sides. So I'll do cube root on both sides. That's legal. So on the left, cube root of r cubed, the cube root and the cube undo each other. I have r. Now, on the right side, fortunately, believe it or not, 8,000 has a nice whole number cube root of 20. 20 cubed, 20 times 20 times 20 does come out to 8,000. The pi in the bottom, though, does not really get too simple. You can get a decimal approximation with your calculator, but basically cube root of pi. That's r. Now, to find the final answer, I also have to find h. Now, if you notice, I happen to have an equation that solves for h. So let me take this equation, take my kind of cumbersome looking answer for r here, and plug it in where I have an r. There's an r squared in the bottom in my equation for h. So I'm going to have h equals, I just put the h on the left, it's a little bit more traditional that way, 16,000 over pi times 20 over cube root of pi squared. So this r squared, I just put in the solution that I found for r. That is h, but you really should clean it up. So h equals, so the top's going to stay 16,000 for one more step. Now in the denominator I have pi times a fraction. On the top of the fraction I have 20 squared. So 20 times 20 is 400. And in the denominator, cube root of pi squared, well, that's going to be pi to the 2/3. The numerator of 2 is from the second power. The denominator of third is from the cube root. So I can simplify that a little bit. So 16,000 on the top and 400 on the bottom. So 16,000 over 400. Let me cancel two of the zeros. I have 160 divided by 4. So that's going to be 40 on top. And then pi, and I have it over pi to the 2/3. So basically pi to the first. And I'm going to subtract my exponents. First power, I'm going to subtract off 2/3. So you can think of the first power as 3/3. That's the first power. So 3/3 minus 2/3 is pi to the 1/3, which actually is cube root of pi again. Pi to the 1/3 is cube root of pi. So that's h. So I have h, I have r. They both have cube root of pi in the denominator. And now the question was what are the dimensions that'll give you that volume of 16,000? It's not. It says what's the minimum amount of material? So I have to go back to my diagram for material, and now that I know what r is and what h is, I can find that minimum amount of material. It'll be in terms of pi unless you want to put in the decimal value. So to make your cylinder, again, I have a circle on the top and a circle on the bottom with radius r. And the area of each one of these circles is pi r squared. And I know from the work I did before the value of r. So it's pi times the value of r is 20 over the cube root of pi. And again, don't forget it, that's the second power. So that's the answer for r, raised to the second power. So that's the area of one circle. I'm going to have two of these, actually. So let me just simplify this a little bit. So that's going to be pi times, so 20, second power, 20 times 20 is 400. And cube root of pi to the second power. So cube root of pi times cube root of pi. Again, this is pi to the 2/3. Again, the 2 from the exponent, the third, the denominator from the index of the root. And now I can simplify this. Pi times something over pi to the 2/3. The pi that's out in front, think of it as pi to the first or pi to the 3/3. So I'm going to subtract 3/3 minus 2/3 because when it's in the denominator to simplify, you subtract the exponents. So that's going to be a equals 400 pi to the 1/3. Or you could say a equals 400 pi to the 1/3 is cube root of pi. Now again, that's one circle. Well, there's another one on top. So there's two of them. So area for my circles is 2 of these. 2 times 400 cube root of pi. So 2 of those would be 800. So the two circles together, the top and bottom of the cylinder, have an area of 800 cube root of pi. So now that takes care of the circles. Now let's do the rectangle. So that rectangle, the area of that is base times height. So the height is h, which we figured out is 40 over cube root of pi. So let's do area equals base times height. So area equals, so the base is the circumference of the circle, which is 2 pi r. So that's going to be 2 pi, not r squared, just r. So 2 pi times, the value of r was 20 over cube root of pi. So that's the base, that's 2 pi r. And that's going to be times the height, because I'm doing base times height. So let me just put it in some brackets. That's the base times the height. The value for h, I have it written down, is 40 over the cube root of pi. So I have to simplify this area again, just of the rectangle. So I have 2 times 20, so that'll be 40, and then pi over cube root of pi. So think of this pi as pi to the first or pi to the 3/3, and I'm going to subtract off a 1/3. So it's going to be 40 pi to the 3/3 minus 1/3 is pi to the 2/3. So that's the base, 40 pi to the 2/3, which is the cube root of pi squared. You could write it that way. Let me leave it like this for now until I deal with this one too. So now that is 40. Now, cube root of pi in the denominator is pi to the 1/3 in the denominator, or pi to the negative 1/3 if we put it in the numerator. So that's the h. So I have base times height. So area, again, just for the rectangle, I have to add in my two circles when I'm done. So 40 times 40 is 1600, and then pi to the 2/3 times pi to the negative 1/3. So 2/3 minus 1/3 is going to be pi to the 1/3, or cube root of pi. So that's the area of the rectangle. So let me add the two circles plus the rectangle. The two circles was 800 cube root pi, plus the rectangle is 1600 cube root pi. So pi to the 1/3, I can call it cube root pi. And now they match. So 800 and another 1600. My total area is 2400 cube root of pi. And again, you can get a decimal value of that with your calculator if you're curious. So how many square centimeters is that? So it'd be 2400. So the cube root of pi, let me figure that out with my calculator. So I put pi on the screen to a bunch of digits, 3.1415. It goes to the end of the screen. I have a cube root button, so I'll take the cube root of that, and it is 1.4659. It goes to the end of the screen. I just leave it on the screen times the 2400 in front. So if you wanted a decimal equivalent, you could leave the pi, but if you're curious, 3515.02053. And that would be in square centimeters. So that's the amount of material you would need to make that 16,000 cubic centimeter capacity cylinder.